Today we are graphing piecewise functions. I'm going to go pretty quickly, so feel free to pause the video at any time and go back and rewatch whatever you need to rewatch. First, we're going to go over different types of functions. A linear function is in the form y equals mx plus b. M is your slope, b is your y-intercept, and it makes a straight line. A quadratic in standard form is ax squared plus bx plus c, and it makes a parabola, open up or down. Your square root function, it can have different shifts, but the parent function is y equals the square root of x, and it starts at one point and goes to the left or the right. Absolute value, y equals the absolute value of x. It makes a v. And a piecewise function is a function that has different parts to it. So you'll have a function for one interval and a different function for another interval. That's what we're going to be working on today. So here's an example of a piecewise. Has a different function to the left and a different function to the right, but it can do more than just that. And lastly, the step function looks like this. So it has many different pieces to it. And that's the notation for the step function. Okay. All right, here's an example of a piecewise function. So the first part of the function is all your y values are 4 for anything where x is less than 1. So here is where x is 1 and all your y values are 4. It is not equal to 1, so you have an open circle. For anything greater than 1, you have the linear function, just x, where your slope is 1. All right. Steps to graphing a piecewise function. First, you draw your boundary lines, and I'll call those your fences. Then you graph each function in the correct neighborhood. And then you need to make sure to do correct open or closed. All right, so if it is less than or greater than, those will be open circles. If it's less than or equal to, greater than or equal to, it will be closed, just like you did in Math 1 and Math 2. All right, so here's your first true example. F of x equals x for x less than 1. F of x equals 2 for x greater than or equal to 1. All right, so let's do your boundary lines. The boundary is at positive 1. So that is the boundary right here. So anything less than 1 is going to be the function x. Well, the function x has a y-intercept of 0 and a slope of 1. So it looks like this. And at 1, there will be an open circle because it's not equal to 1. All right, for greater than or equal to 1, it is all the values are 2. And this is going to be a closed circle, and it's going to the right because it's greater than or equal to 1. So everything greater than or equal to it will be closed. All right, the domain of this function, remember, domain is left to right. So to the left, it goes to negative infinity. Then at 1, there is an open circle here, but there's a closed circle there. So it does have a value at 1, and then it has a value all the way to the right. So the domain is negative infinity to positive infinity. You could also say all real numbers. The range, remember, is bottom to top. So the bottom of the function does go to negative infinity. And then as we're tracing from bottom to top, there's this gap for your y values. There is a gap at 1. So at 1, there's an open circle for your y value, so you're going to use a parenthesis. And then it jumps to 2, and your y values never get greater than 2. All right, let's do another one. Here, our boundary line is at 0. That's the cutoff point. So to the left of 0, it's the x squared, your parabola. So x squared starts at 0. I'm going to put an open circle because it's not equal to it. And let's plug in some values. So if I plug in -1, -1 squared is +1. -2 squared is +4. So the parabola looks like that. Okay. Then to the right of 0 is just the horizontal line of 3. Okay. All right, domain left to right. So to the left, it goes forever. And as I trace it, it doesn't skip any x values. And it goes to the right forever. You could also say all real numbers. The range, bottom to top, it starts at 0. I'm going to put a parenthesis because there's an open circle there. It starts at 0. And then it goes to the top forever. It never skips anything because right here, where it looks like you think it might skip, it doesn't really, because here there is function here. If you come back to this example, there is nothing on the graph from 1 to 2. But here, there is the function. So it goes to infinity. You could also say y is greater than 0 is another way to write that. All right, number 3. This one has 3 functions. This piecewise function has 3 different parts. -1 is one of your fences, and 3 is the other fence. Okay. All right. To the left of -1 is the horizontal line at 3. And it's an open circle, and this time it's going to the left because it's less than -1. My middle section is this function, -x. So that's a line, a straight line. It has a y-intercept at 0 and a slope of -1. So it goes down 1 over 1. So let's look and see if I should have open or closed circles at the ends. So on the left, I should have a closed circle. And at the right, I should have a open circle. And then this one is another horizontal line at -2, closed circle going to the right. Okay. All right, domain left to right. All right, on the left, it goes forever. And as I trace it, it never skips any x values. So -infinity, +infinity, or you could say all real numbers. Range bottom to top. At the bottom, it does not go forever. It starts at your y value of -3, and there's an open circle there, so I'll use a parenthesis. Then it does take on all values till you get to 1, and then there is this gap. So we need to stop it at 1, put a bracket, because that's a closed circle. Then it jumps up to 3, and the y values never get any higher than 3. All right, number 4, this one also has 3 sections. Our boundary lines are at -2 and +1. The one on the furthest left is your horizontal line -1 and open circle, and it's going to the left. In the middle is the absolute value function, x + 1. So remember that shifts it to the left 1. So I will have my minimum value will be there, and it goes up. All right, it will have a closed circle here and an open circle there. And then the last section is a horizontal line at +2, and that will close in this circle right here because it is equal to 1. Okay, all right, domain and range. Domain left to right. To the left, it goes forever. Then your x values, it never jumps any x values. And your range starts at -1. I know there's an open circle here, but there's closed circles here. So it does have the value of -1. Then it jumps up. Your y value, the next y value available is a y value of 0. And the y values go up to 2, and then they stop. All right, number 5, 3 sections, 2 fences, a fence at -2, a fence at +1. Furthest left, you have a horizontal line at 3, open circle going to the left. In the middle is x cubed. So let's plug in some values. So if you plug in 0, 0 cubed is 0. So 0, 0 is a point. If you plug in 1, 1 cubed is 1. And this would be a closed circle because on this boundary line, it's equal to it. Plug in -1. -1 cubed is -1. And -2 cubed is -8. So 6, 7, 8. So somewhere down here. And it actually does some curving through these. Okay? So plugging in your values. And then here we have x squared plus 1. That's a parabola that shifts up 1. So it would start at 1. I'm not going to put a point there because I don't want to graph it till I get over here. If you plug in 1, so 1 squared is 1 plus 1, so that would give you a value of 2. And if you plug in 2, 2 squared is 4 plus 1 is 5. So the parabola goes through that way. Okay. All right, domain left to right. So it goes to the left, -infinity. It never skips any x values. So that's all real numbers. And your range, it goes from -8 all the way to 1. Then it jumps up to 2 and goes to infinity. You can also graph these in Desmos. Now you're going to have to pay attention to what intervals to graph them in, but you can help find points in Desmos as well, get you a better idea. All right, here's an on your own, so pause the video and then hit play once you've tried it on your own. All right, so boundary line at 1, your parabola is going to go down 4. And then let's see, if I plug in 1, 1 squared is 1, minus 4 would give you -3, open circle. And this one is going to the left, so I need to plug in values this way. So if I plug in 0, 0 would be at -4. Plug in -1, -1 squared is 1 minus 4. 1 minus 4 is -3. Parabola symmetrical, so I should have known that. Plug in -2. -2 squared is 4. 4 minus 4 is 0. So it looks like that. Open circle there. This one is going to be a straight line. Your y-intercept is at 5. I'm not going to put a point there because I'm graphing to the right of this line. And then it goes down 3 over 1. Down 3 over 1. Okay. All right, your domain is -infinity goes to the left forever and to the right forever, or you can say all real numbers. Range, it starts at -4 and goes to infinity. Oh, I'm sorry. It goes to the bottom forever, and then it goes to the top forever, and it doesn't have any gaps for the y values. All right. Lastly, writing explicit and piecewise. So writing explicit function, this is absolute value. You know that it has gone right 1, so that would be -1 in the parentheses, and it has shifted down 3. So that's what the explicit function looks like. Piecewise, there are 2 parts. You could say that there is a linear function to the left and a linear function to the right. So my linear function to the left has a negative slope of 1 and a y-intercept of -2. And that's for all values less than and equal to